Hello everybody, Chris here, and in this video I want to show you how to add super basic platformer movement to a 2D game inside of Godot. So first off, I'm just booting up a brand new project here. You can see that we're in 3D view. So you can go between 2D and 3D view in any Godot project super easily. Just press F1 on your keyboard, or you can click up here to go to 2D instead of 3D up at the top. F3 goes to script, F2 goes back to 3D. So let's be in 2D mode, and we're going to set up a really simple platformer characters. So let's start off by creating the character which can move. So in order to get our 2D character to move, we want the root of that character to be a 2D kinematic body. So I'm going to click other node here, and we're going to select kinematic body 2D from the list. So just type in kine, and you should be able to find kinematic. So kinematic body 2D, create that node here. And a kinematic body 2D is going to require you to have a collision shape. So since a kinematic body 2D is a physics object in the game, it's going to need a collision shape to define where this object should collide with other objects, basically to bump into them, or maybe you need them to slide along a surface. All of that is calculated with collision shapes. So I'm going to right click on the scene here for kinematic body 2D, add a child node, and we need to find a collision shape 2D. Okay, and this collision shape requires an actual shape. So we define the shape over in the inspector on the right. So where it says shape, we'll take the collision shape and we will give it a capsule shape. So in this tutorial, we're going to use the default Godot icon as the sprite for this character, which is a rectangle. But in order to have this character slide along surfaces that may be uneven properly, we're going to get much better results if we use a capsule shape 2D, and most platformer characters would be humanoid in shape and therefore not really a square but more of a oval anyway. So let's use capsule shape 2D. Now we can see our shape defined here, but we have no sprite to actually show the character. Now we can add a sprite by right-clicking on our root node and adding a child node. So even easier though, we can just bring in an image that we want to use as the sprite for our character onto the scene here. So I'm going to drop it right about there. That's not the position we want it to be. Adding it this way, you can't have it snap immediately, but if we come up here and check use smart snap, then we'll be able to have this icon sprite snap to the parent really easily just by dragging it up here. I guess it's actually snapping to the grid lines. But either way, if we get it to the transform of 0, 0, then it's going to be positioned where we want it to be. You can see this little cross for the character as well. One thing to note is that if we're going to move the character, we don't want to actually move the offset of this icon. So if I try to left click right about here, we'd actually be dragging the icon but not the character. And we can correct that really easily by selecting the root node. And then if we come up here to this icon, make sure the children are not selectable. Then now if we click on our character and we move it around, we're moving the entire thing rather than the sprite icon. So that's going to be really handy when we want to keep everything together. You can toggle this on and off if you do need to move a child component for some reason. So we have our character here. Let's go ahead and rename the kinematic body 2D to say player. Just double click on the name of the node and you can save it there. And now let's go ahead and save this player as a scene in our project. So this is going to be a .tscn file. You can organize your structure however you want, create folder up there. I'm just going to leave everything in the root directory for right now since this is just a really simple tutorial. So let's go ahead and hit save. If you don't already know, for scenes, basically just about everything you use in Godot, everything that has nodes is going to be either a scene itself or a part of a scene. So if you have a level, that's a scene. If you have a UI component, that can be a scene or part of a scene. And if you have a player, then generally you would create a separate scene for that. So it's just something you can instantiate into other scenes in your game. So a scene is going to be composed of the base scene and other scenes beneath it. Okay, now let's go ahead and create a object that this player can bump into. So I'll go to scene, new scene. And this time we could get away with just using 2D scene here as the root node because these blocks aren't going to move on their own. So we don't need to apply any movement to a static 2D object. But I guess we could use other node if we want and just make the base a static body 2D as well. Not necessary here, but we can go ahead and do that. So our static body 2D, we're going to rename this to block, since it's the root node for our block. And this is going to require a collision shape 2D. So let's add in a shape, collision shape 2D, enter. And for the sprite, let's also use the icon.png. I'll just drag this in here. With smart snapping enabled, we can just position this right at the center there. And okay, we do want to make sure that this isn't a child of the collision shape. So let's drag that up and make sure that it's organized right under block here. So just keep in mind what is a child of what inside of your scene. Now this collision shape 2D also needs a rectangle shape. So let's go ahead, click here, and put in a rectangle shape. Since we made the player a capsule shape, when we use the move and slide function on the kinematic body to make it move left and right, if there's a little bit of elevation difference between, let's say, the blocks, it should be able to jump right on to the next block and continue moving rather than getting stuck on the edge. So let's just make sure that this shape has basically the same dimensions as the icon. If we actually pull this beneath here, we can see the collision shape on top. That'll make it easier to edit. So let's position it right about there. And now we can prevent ourselves from moving the children objects with that button over here. So you use that on the block node. And now we can drag the block wherever we need it to be without messing with the children node. But if we need to, we can always click on a collision shape and then shrink it as necessary. So I think that should be pretty good. Let's go ahead and hit Control S and save the block scene to our project. One last thing I want to change about the block is the visibility. So in Inspector Visibility, I want to change the color for this block. So we're going to change the color over to something like a purple. And let's just set it right about there. The reason for this is so that we can tell the difference between our player and the block. Now, obviously, if you're working on a real project, you're going to have other art assets. But doing it this way is okay for prototyping purposes, just to make sure that the mechanics themselves work. So let's go ahead and hit Control S, save this scene again. And now we need to add in one more scene, which is the level scene. So I'm going to click up here, add a new scene. Let's create a 2D scene. I'm going to rename this level. And immediately I'll just hit Control S and save the level scene in our root of the project. So save that. And now if we want to add a player or players and a block to the scene, we can just drag them in. Now by default, the camera is going to show the region to the down and to the right of this 0, point. So this is going to be the top left corner. Of course, you can modify that with camera components later on, have the camera follow the player rather than being a static view. But for this tutorial, that's just going to be how it's going to be. Let's drag some blocks into the scene. So I'm just going to do this kind of randomly. And let's actually add different elevations so that when we add the move and slide, that we can see that it's actually going to move up and down a little bit on these objects. Now with move and slide, there's the ability to set the threshold for where a slope would be considered to a lower value, or you could make it 0 if you do want a character to just get stuck on every single edge here. But you may prefer that a character can just kind of walk up steps. So that's where the default slope value can come into play. And let's add a player object here. So we'll go ahead and hit play in the scene. You can see that no main scene has ever been defined. So let's set the starting scene for our project, and we'll select the level scene for that, of course. So when we do that, we have our scene. We have the player, and even though the player is using a kinematic body 2D, we don't get any movement. So we do expect the static objects to not move, but a kinematic body, generally, you're going to want some movement with it. So the difference between a kinematic body 2D and a rigid body 2D is that a rigid body 2D will be affected directly from calculations based on force in the physics engine, whereas a kinematic body 2D, you have to define the movement manually in script. Now for a typical old style 2D platformer, kinematic body 2D tends to give you the look that you'd want with rigid body physics. sometimes the movement isn't going to be precisely how you want it to be because there'd be multiple forces acting on it rather than setting the movement to a specific value in a script. So let's close out here, and we need to go into our player scene. Now you can see that because we were instantiating or creating a copy of the scenes that we had created previously, the player and the block, that we have the ability to jump into those scenes inside of the editor. So when we click on these, we're opening up the original scene, which if we make changes to is going to affect any of the copies of the scene for any values where you haven't created a custom value. So if I went over here to the block and I changed the visibility, let's say the modulate value over here, this is only going to affect the copy here. As long as we don't reset this to the default value, then if we change the values of these blocks in another scene, it's still going to have this color here. It'll only update the color for the ones that are still using the defaults because the defaults are being pulled from the scene file. Hopefully that makes sense. So in other words, the defaults come from the scene file, but the instantiated copy is free to set its own custom values. So let's jump into the player scene now, and we need to add a script to this in order to get movement. So let's right click here and attach a script. It'll be player.gd, and we can see up here that it inherits from Kinematic Body 2D. Kinematic Body 2D has what we need to move our player around the scene. So let's go ahead and hit create here. So for this tutorial, we're going to need three variables that we want to be able to change in the editor in order to define basically how fast our character can move. So let's go ahead and delete. Actually, we can just delete all of this junk. The only thing we need is extends Kinematic Body 2D at the top. So up here at the top, we're going to want to put export, implying that this variable is viewable and editable from the inspector for a node that has this script attached. In parentheses, I'm going to define the type of the variable as a float, meaning a number that can have a decimal point value. And we'll put var for variable, and I'm going to call this move speed, and we can default it to 500. So next variable, export float, and we'll call this jump impulse. I'll try setting this to 1,000. And then export float variable gravity, and we'll set this to 100. Now technically, you could have a gravity be a global value that all of your characters are going to pull from. If you go into project and then project settings, you can actually search here that there is in fact a default gravity value. And I think this might be used by default more with 2D rigid bodies, but technically that value exists there. But in this case, we're just going to have the gravity defined in the player script itself so that we could just set custom values here for how floaty the character should be. So if we have a really high gravity value, then the character will fall to the ground very fast. But if maybe we want it to have the illusion of some air resistance, a more floaty character, then we can set a lower value for the gravity. So in order to run physics calculations on our kinematic body, we should do that in a function called physics process. So you can see this is function underscore physics underscore process, and then delta is the parameter that gets passed in here. So delta is the time between frames. So every time your physics calculation runs, it's going to start a timer. And then that timer comes back as the next delta passed in for the next run of physics process, the time since this physics process function has occurred. Now we're not actually going to need to use the delta directly because when we run move and slide on a physics 2D body, the delta is already accounted for. So down here, we're going to want to put in move and slide. And the reason we don't need to define any objects which are calling this function is because it's the kinematic body itself that's doing this. So this is the same as if we put self.move and slide. We can just drop the self because it's implied here. And then we need to give it a direction for up. So the velocity, we can kind of define that up here as a var velocity. And I'm going to put semicolon vector 2 just to kind of define what sort of variable this is. We'll pass in the velocity here, and then for the up direction we want vector 2 dot down, I think, since down is actually up in terms of values. So down can be -1, but -1 is actually facing upwards on our screen. And now this function actually returns a velocity. So we'll set the velocity equal to move and slide. And now we just need to update the import here for the move and slide. When I think about it though, maybe we should have a separate variable to make it a little bit more clear here. So I'm going to call it variable next move. And I'm going to set this equal to velocity every time the physics process runs. So then we'll have next move down here. And after the move actually occurs, the velocity gets returned up here so that we can use it in the next physics process as the base here. This isn't going to change how it functions directly, but I think if we're just using the variable velocity all over the place here, it might be a little bit more confusing to look at. So the next move, the base for this, is going to be based on whatever the velocity was at the end of the last move and slide. And then what we're going to want to do is we're going to take the next move dot y and we're going to add the gravity. So I'm going to do plus equals gravity here. So the gravity value gets added on to the y for the move. So when move and slide calculates the move for a character that's falling and we have the gravity, it's going to bump into the ground eventually. And then the velocity y value that gets returned from this is going to be 0 or roughly that, since it can't actually move past a static object 2D. It's just going to be stuck at the ground. So it's going to have a y velocity of 0, which is going to be returned up here. Okay, so now we can go ahead and try hitting play. And we should have the character fall to the ground. Okay, that worked a little too fast. And as we can see, I kind of forgot to define the rectangle shape for that block. But overall, that's working pretty good there. Maybe we want to drop the gravity by about half. Let's try that. So default gravity of 50. Let's go into the block scene. F1 to get into 2D view. And let's make sure that the rectangle shape is where it needs to be. Maybe it wasn't actually the rectangle shape that needs to be defined. It's the player shape. So I'm going to drag this collision shape down to the bottom so we can actually see it on top here. And we can see, yes, the capsule does not fit our sprite very well. So let's stretch these edges. Just make it more of like a perfect circle for this character. Now if we hit Control S and save, the character should get stuck on the ground a little bit better there. So overall, that's going to work all right there. Let's go ahead and close that scene out. And now that we have gravity working, we also need to add in some input. So left-right movement and then jumping. So let's define a section up here for get player input. And the player input we need to get, or at least part of it, is the axis input. So I'm going to set axis equals to a vector 2. And let's add a couple new lines here, one for the X and one for the Y. So if we reference the input library, we can get action strength for left and right. So we want in parentheses UI right, as in moving to the right. And then we're going to subtract that from input.get action strength, in parentheses UI left. Okay, and the reason we subtract the left value from the right, a positive value is going to be making the character move to the right. So that's why we don't subtract the UI right. But the negative value is going to make it move to the left. So when the character presses left down, or the player rather, then that is going to want a negative value. So that's why we subtract the left, but we add the right. And if we have both pressed at the same time, then they're going to cancel each other out. So let's do the same thing with the y-axis. Get action strength. UI down. So down is actually a positive value when we're talking about y. So the stronger our y value in terms of movement, the faster the character is going to go downwards. So we want UI down minus UI up. And now that that's defined, we can take the xy values here and use them how we want. So let's define a couple other sections down here. I'll say x move, and then down here we can have y move. So for the next move.x, we're just going to want to set the velocity to a value on every physics process frame. So it's not going to really carry over from the previous frame. It's just going to be set on every frame as a new value. So this is going to be the axis x times the move speed. So if the character is moving to the left, axis X is going to be negative. So we're going to get a negative final X move value, and the character will move to the right. And then the character will move to the left. Or if axis X is positive, then we're going to get a positive final X move value, and the character will move to the right. Okay, so now let's go ahead and hit play and see how our movement works. So kind of nice here. It's able to move up the slopes of the differently positioned blocks. Now, because our shape is a little bit on the spherical side, it can kind of slide off the edge here a little bit easily. So we can use different kinds of shapes to define how it should kind of slide. Maybe you do want the slide in the case of like a very circular shape, or we could adjust it. Let's go into the player here and the collision shape 2D, and we can adjust it so that it's more of like the original capsule shape. The collision shape does not need to be a perfect outline of the sprite necessarily. So in this case, because the width is a lot lower, we should get a lot less of that sliding off the edge. Let's go back into play mode. So let's go ahead and hit play now, and we can kind of test out the movement here a little bit. Okay, so we can see that the character can kind of move up the slopes, also kind of slides down on the edges. Some of this is going to depend on what kind of collision shape you're using for the character. And there are a bunch of optional parameters that you can set for move and slide as well, which can kind of define what the character can and can't do. But at a basic level, we have the left and right movement. And I think in many cases, you would want it to be able to at least move up the slope. So that's going to be quite okay there. Maybe we would want to bump up the gravity and see if that changes anything. So I'll set the gravity to 150, and let's see how that kind of affects things. So it's a lot less bouncy now at the very least, but maybe it falls too quickly to the ground. Depends on what you're going for. So maybe I'll set it back to 100, kind of an in-between. So the final thing we're going to need for this basic tutorial is to add jumping. So the way we can get jumping is by setting a jump key. So first we need to actually define a key that we can press for that. So I'm going to go up to project settings. Let's go to the input map and add in a new action. I'm going to call it jump, and we click add. So down here at the bottom, we can define a key to press to get that action to occur. Add event, key, going to do spacebar, hit OK, hit close. And now we've defined a jump key. So we need to see if that key is pressed, right? So var is jump pressed to input dot is action just pressed. So we're going to set that equal to input dot is action just pressed, and we're looking for the jump action. So the reason we use just pressed rather than pressed is that we only want this to occur on the moment we press the spacebar, not if we're still holding it down half a second later. This will make it so that when we press jump, it's going to add a one-time impulse rather than holding jump down to continually increasing the speed. Though you could do it that way instead if you also prefer. That would be more like a Mario kind of jump where you actually need to keep holding the button down to get the character to move to its maximum height. So is jump pressed equals input dot is action just pressed. And then we're going to modify the next move.y if that is the case. So if is jump pressed, then we're going to add the jump impulse to the y move. So if is jump pressed is true, then we're going to subtract the jump impulse from the next move. So next move.y minus equals jump impulse. And the reason that we subtract it is because we want the character to go up. Up is negative in Godot 2D physics. So if we have a negative final move for y, the character is going to travel upwards. Okay, so that is actually all we need, I think. So let's go ahead and test our final result. We can move left and right. We can hit spacebar to jump. And as things are currently, we can hit spacebar many times to keep jumping. We can even spam it if we want and, keep going till the moon, which is probably not what you actually are going to want in the end. So I'm going to make another tutorial on how to check if your character is on the floor, on the wall, or on the ceiling. It's actually really easy to do in Godot with Kinematic Bodies 2D. So that's pretty much going to be it for setting up some really basic platformer controls and having some objects for your character to bump into. So I've been Chris. I hope all of you enjoyed taking a look at this introductory video for creating a simple platformer in Godot. Thanks for watching, and I'll see you all in my future video content.